In this video, I am going to discuss about Chapter 1, Exercise 1.1 linked to HCF and LCM. So, in the last class, we discussed about the prime factorization, and that topic is very important for finding of HCF and LCM. First, I am going to discuss what about the HCF and LCM. So HCF, what is HCF? Is highest common factor. Highest common factor is HCF, and LCM is least common multiple. What is LCM? Is least common multiple. Observe how to define. HCF is product of the smallest power. Product of the smallest power. What power we will be used? Smallest power. Product of the smallest power of each common prime factors. Each common prime factors in the numbers. Observe, if we are having two numbers and we want HCF of two numbers like 2 and 4. I am having two numbers 2 and 4. I want HCF of these two numbers. So what will be the HCF and LCM? So I am solving this for the HCF and LCM both. I am having two numbers 2 and 4. I want what? I want HCF and LCM. So prime factors of 2. 2 is a prime number. So its prime factor is 2 into 1. It is having only two factors. And prime factors of 4 is what? 2 into 2 into 1. Yes or no? Both are small number. So we can, I am writing directly. If we are having big number, then we will use long division method. Whatever we used in the prime factorization class, we will use that method to find prime factors of numbers. So now this and this two numbers I am having, I want HCF. What is the HCF? Highest common factor. And what is the definition? Product of the smallest power of each common prime factor. Now in a power terms, I can write 2 power 1, and this can be written as 2 power 2 like this. So in these examples, I am having only one prime factor I am using. 2 in this number, 2 in this number also 2. One is neither prime nor one is not neither prime nor composite. Okay, so HCF will be what? HCF of 2, 4 will be product of the smallest power of each common prime factor. Now after solving the prime factor form, we are having this 2 having power 1, 2 power 1, and this one is having 2 power 2. And in both we are having only 2 as a common factor. In 2 and 4 we are having 2 as a common factor. And in the HCF, listen carefully, in the HCF we will use product of the smallest power of each common prime factor. So in both we are having 2 as a prime factor, and 2 is in a both, and it is a common, and we will use what? Smallest power. This is the small, then this one 2 power 1 is smaller than 2 power 2. So we will use smallest power. So we can say its HCF is 2 power 1, or finally we can say 2. This is the HCF. But for the LCM, observe, for the LCM of 2, 4, what is the definition? Least common multiple, product of the greatest power. In these two numbers, we are having only one prime factor, that is the 2. Now, smallest common prime number is 2, and but in the least common multiple, product of the greatest power of each prime factor, not common. In the HCF, we are using smallest power of common prime factor, but whatever numbers having prime factors, we will use greatest power. Now in both number we are having only 2 as a prime factor, and 2 having power 1 there, but there 2 having power 2. So we will use greatest power for HCF. So its HCF will be what? 2 power 2. So result will be 4. So we can say HCF of 2 and 4 is a 2, but LCM is what? 4. Simple. In the simple way we can say, in the HCM we will use common term. In the HCF, highest common factor, in the highest common factor we will use common prime factor, each common prime factor. Common means two numbers are there, we will use common prime number. So this one 2 and this one 2 is only one time, and this is common to this one. So we can write one time only 2. 2 is common. Now there is a 2, but there is not 2, so we cannot take this one. So directly we can say, if we are having two numbers and they are common, they are having factors and common in a both, then we will use common one. Now in which we are having 2 into 2, only 2, and in which we are having 2 into 2. So which one is common? 2, only one time. This 2 is there, this 2 is there. So we will take in the HCF. But this 2 is there, but in which we are not having. We used this 2. So only one 2 is common. So we can say smallest power of each common prime factor. So this is also correct. This one is the small, and this will be the common to this one, 2 power 1, and there is a 2 power 2, there is a 2 times, so there is a 1 times, only one time we are having common. So HCF having common prime factor in the नंबर्स के अंदर जो कॉमन होगा, अगर 2 नंबर हमारे पास है, 3 नंबर हमारे पास है, जो प्राइम नंबर दोनों के अंदर आएगा, दोनों के अंदर जो आ रहा होगा वो ही HCF के अंदर काउंट होगा. उनका मल्टीप्लिकेशन, उन कॉमन नंबर्स का मल्टीप्लिकेशन ही वी विल कंसीडर इन द HCF. बट इन द LCM वी विल कंसीडर ईच प्राइम नंबर इन्वॉल्व इन द नंबर्स. If we are having 2 numbers, 3 numbers, and they are having different prime numbers, we will use. Why? Each prime numbers involved in the prime factors, we will be used in the LCM. So this topic will be more clear once we solve the questions linked to exercise 1.1. We already covered in the prime factorization question number 1 by using prime factorization method, and that process is important for solving these questions. These questions linked to find HCF and LCM. This is the basic definitions of the LCM and HCF. But now how we will apply? By using this formula, this definition. So I am going to start question number 2, first one. Now what is the question? I am just reading. Question is what? Find the LCM and HCF of. Find the LCM and HCF of the following pairs following pairs of integers. We want HCF and LCM and HCF of the following pair of the integers. In the pair we are having two integers and we want HCF and LCM. What we want? LCM and HCF of following numbers. They are in the pairs, two numbers are given, or we want HCF and LCM. Question number second, first one I am taking there. Question number second, first one. And what is the question? 26 and 91. What is the question? Question number second one, exercise 1.1. It is having two numbers, 26 and 91. What we want? HCF and LCM. What we want? HCF and LCM we want to find in this question. So how we will solve? First, whatever numbers given, use prime factorization to find prime factors. So we will do long division method. By using long division method we will find the prime factors of 26 and 91. So I am using long division 26. Now 26 is divisible by 2. Why? Because unit place is having 6. If unit place is having 0, 2, 4, 6, 8, then we can say that number is divisible by 2. So it is divisible by 2 one time, 3 times. Now after dividing we are getting 13, and 13 is the prime number. And what about the prime numbers? Having only two factors, one in itself. Smallest prime number is 2, so we are using 2 there. Now 13 is the prime, so it will divisible by 13 itself. So this is the prime factors we are getting. Now next number 91. 91, first divide by 2. Can we divide 91 by 2? If unit place is having 0, 2, 4, 6, 8, then only we can divide by 2. Unit place is having 1, so we cannot divide this number by 2. Then next prime number is 3. Can we divide this number by 3? No. Why? Because sum of digits of a number is 10 and it is not a multiple of 3. So we cannot use what? 3. Next prime number is 5. Can we divide this number by 5? No. Why? Because unit place is having 1. For the divisibility of the 5, we require unit place equal to 5. So we cannot divide by 5. Now next prime number is 7. Can we divide this number by 7? Try. Now I am dividing by 7. How many times it is going? 1 times. Remaining 2. 8, 9. 9 minus 7, 2. 21. Yes, we can divide. 21. How many times? 7 3 ja 21. 7 3 ja 21. So now 91 is dividing first 7. Then we are getting 13. Now it is divided by 13. So these are the prime factors by using prime factorization. So what we are getting? 26 equal to 2 into 13 and 91 equal to 7 into 13. 7 into 13. So these are the prime factors of 26 and 91. 26 having 2 and 13 as a prime factors, and 91 is having 7 and 13 as a prime factors. Now we want HCF and LCM. What we want? HCF and LCM. For finding HCF, how we will find HCF? HCF is the highest common factor. What number is common in both factors of the numbers? Now we are having 2 there, but we are not having 2 in the 91 factors, so we cannot use 2. We are having 7. We are having 7 there, but we are not having 7 in the 26, so we can also not use 7. So next common prime factor is 13, and that number is in both So we can say smallest power of each common prime factor. So in both, what number is common? 13. So 13 will be the HCF. 13 will be the HCF of these two numbers. HCF of 26 and 91 will be 13. Now LCM. How we will find the LCM? LCM, observe, we are having long division method, but by using prime factorization, how we will find? I am showing there. In this method, we are having factors. We completed the prime factors, prime long division method by using this one. We are having factors of 26 and 91. Now in both 26 and 91, how many different types of the factors we are having? In both we are having some different types of the factors, and write each different types of the factor in the LCM. So in which we are having 2, 13 and 7. In both, इन दोनों के अंदर कौन कौन से प्राइम नंबर्स काम में आए हैं? 2 आया है, 7 आया है, 13 आया. So these all, whatever prime numbers, each prime factors involved in the number, in the LCM, what we will do? We will write, we will product each prime factor involved in the numbers. So in these numbers, what prime numbers are involving? 2, 7 and 13. We will write there 2 into 7 into 13. We will write there like this. Now each prime number involved in these numbers are what? 2 into 7 into 13. Now power. What power? Greatest power of each prime number. So 2 is used one time, so we will use 1, and now we can write like this also in prime factors form: 2 power 1, 13 power 1, 7 power 1, 13 power 1. Now maximum power of 2 we will be write in the LCM. So it is having only 1, so we will use 1 there. Maximum power of 7, 1, 13, 1 times it is using. So we can say 2 power 1 is 2, 7 power 1 is 7, 13 power 1 is 13. We will multiply 7 2 ja 14, and 14 into 13, product will be result. So what will be the product? 13 4 ja 52, 2, 5 is remaining. 13 1 ja 13, and 5, 13 plus 5 plus 3, 13 plus 5, 18, 182. So what will be the LCM? 182. Observe what I am doing there. For LCM and HCF, so simple process. For finding LCM and HCF of two numbers, first find prime factors, and for finding prime factors we will use long division method like this, prime factorization method. Then write like this. Now come on the HCF. HCF क्या होगा? जो इन दोनों नंबर्स में कॉमन होगा, जो हमारे पास 26 के जो फैक्टर आए और 91 के जो फैक्टर्स है, जो नंबर इनमें कॉमन होगा. 2 यहाँ है, इसमें नहीं है, we cannot take. 7 is there but 7 is not there, we cannot take. 13 is there, 13 is there, so we will take one time only. जो कॉमन होगा उनका मल्टीप्लिकेशन करेंगे. सिर्फ देयर इज ओनली वन नंबर, सो आंसर विल बी दिस वन. इफ अनदर नंबर इज ऑल्सो 2 is there, we will take 2 and multiply by 2, but that time we are having only 13, so answer will be this one. Getting? LCM में क्या होगा? जो इनके फैक्टर्स आए हैं उनमें जो भी प्राइम नंबर्स, whatever prime numbers used in these numbers, we will write 2, 7 and 13, and then take power. And how we will consider power? Maximum power. This one is coming one time, this one is coming one time, this is one coming one time, this is coming one time. So we are using maximum power 1. So we are using what? Maximum power. Now in this question maximum power is 1. Then we are multiplying. 7 2 ja 14. 14 into 13 we will do 14 3 ja 50, what? 14 2 14 3 ja 14 3 ja 14 1 ja 14, 14 2 ja 28, and 14 3 ja 42. 2 will be there, 4 is remaining. 14 1 ja 14, 14 plus 4 18. So 118 will 182, not 182 will be the LCM of this number. So this is the way of finding of LCM of two numbers. Now we want to verify, and how we will verify? In the question given, verify that LCM into HCF equal to product of the two number. And we know if two numbers LCM and two numbers HCF, LCM and HCF, LCM of two numbers and HCF of two numbers product will be product of both numbers. How? So what we can say? HCF into LCM, HCF into LCM equal to product of two numbers. If two numbers are A and B, then we will product both, will be equal to product of HCF and LCM. Now in this question, what is the HCF? 13. And what is the LCM? 182. LCM is 182. Now what is the A and B? A and B are given numbers. A is 26 and B is 91. Once left hand side equal to right hand side, then what we can say? We are getting correct HCF and LCM, otherwise there is some mistake. So how we will do? Just multiply. If we know the table well, then we can easily to do. 13 2 ja 26, 2 is remaining. 13 8 ja 104, and we are adding 2. 6 0 1. 13 8 ja 104, 104 plus 2 106, 106, 6 will be there and 10 is remaining. Now 13 1 ja 13, 13 plus 10 23. We are getting in the left hand side 2366. In the right hand side, what is the product? I cannot know this table, so we will product this one like this. 26 multiplied by 91. I am doing multiplication by 1, 6 and 2. Leave this number, space will be there. Now how many times it is going? 9 5 ja 54. 9 5 ja 54. 4 will be there, 5 is remaining. 9 2 ja 18. 9 2 ja 18. 18 plus 5 23. Yes, result is same. We are getting same result. This is 2366. So left hand side is equal to right hand side, so we can say HCF is 13 and LCM equal to what? 182. Observe, I am again revising this one, what we are doing in this question, how we are solving. Just observe. If you know starting questions well, then you can solve easily to other questions. Yes, in this question, what is the given? Find the LCM and HCF of the following pairs of the integers and verify this one. Or for verification, we require product of HCF and LCM will be equal to product of two numbers, given two numbers. So for solving this one, what we will be do? First we will do factors. And how we will do the factors? By using prime factorization method. So we are doing factors, we are having these factors. Then HCF जो होगा वो दोनों में क्या होगा? कॉमन. जो नंबर इन दोनों के फैक्टर्स के अंदर आ रहा है उसको ले लीजिएगा वन टाइम, और जो भी फैक्टर्स है, कॉमन फैक्टर्स, उनको मल्टीप्लाई कर दो. दैट इज द आंसर. But in the LCM, whatever prime factors used involved in these numbers, we will take one time. जो भी प्राइम नंबर काम में आए उनको एक टाइम लिखेंगे, और जो नंबर्स के अंदर, फैक्टर्स के अंदर जिसकी मैक्सिमम पावर आई होगी, जिस नंबर के अंदर, if 2 is one time but 2 will be 2 times there, then we will consider 2 power 2. अगर यहाँ 2 एक बार आया, इसमें 2 बार आया है, तो 2 2 बार हम कंसीडर करेंगे. ये होती है मैक्सिमम पावर कंसीडर करना. देन we are verifying product of HCF into LCM will be product of given numbers. 2 numbers are given, we will multiply both, must be equal to product of both, and we are getting and verified left hand side equal to right hand side. So this is the process of finding of LCM and HCF of 2 numbers. Now I am going to take next question. And what is the next question? I am writing there. Question number second one. First, second one. Question number second one. What is the question? Question is 510 and 92. So we will follow same process. First find the prime factors, then we will find HCF and LCM. So I am using long division method. 510, unit place is having 0, so it will be divisible by 2. How many times? 2 times 1, 5 times 1, 5 times. Now it is not divisible by 2. Next prime number 2 will be used. Not prime number, not 2, 3. So for divisibility of 3, we will check the sum of the digits of the number. 2 plus 5 is 12, and it is divisible by 3. Yes, it is divisible by 3. It is a multiple of 3, so we can use 3 there. How many times it is going? 8 times. 8 3 ja 24. 1 is remaining. 8 5 ja 15. Now what we will do? 85. Can we divide this number by 3? We will add digits of the numbers. 8 plus 5. 8 plus 5 is what? 13, and 13 is not multiple of 3, so we cannot use 3. Next prime number is 5. Yes, unit place is having 5, so we can divide this number by 5. Then how many times it is going? 1. 3 is remaining. 7 5 ja 35. 7 times it is going. And next prime number, this is the prime number, so we will use directly. How many times? 1 times it is going. So these are the prime factors of 510. Now next number I am taking there. What is the next number? 92. Prime factors I am doing. Unit place is having 2, so it is divisible by 2. How many times? 4 times. And what is the remaining 1? How many times? How many times it is going? 6 times. 6 2 ja 12. Now again it is having 6, so it is divisible by 2. How many times it is going? 2 times, 3 times. Now 23, and 23 is a prime number, so we cannot divide any other number. We will divide directly 23. And what is the remainder? This one. Now write 510 can be written as 2 into 3 into 5 into 17, and 92 can be written as 2 into 2 into 23. And first I want what? HCF. HCF is what? HCF is a, what is HCF? HCF is a highest common factor. HCF निकालने के लिए जो नंबर कॉमन होगा उसको कंसीडर करेंगे. So what number is common? There is only 2 is common. 2 is there, 2 is there. There is 3, but there is not 3. 5 is not there. 17 is there, 17 is not there. 23 is there, 20 is not, 3 is not there. This 2 is there, but in which only 1 2. So we have considered. So this is not common there. So only 1 2 we will write there. This is the HCF, highest common factor. And highest common factor is smallest power of each common. जो भी हमारे फैक्टर्स आए हैं उनमें जो कॉमन जो है, कॉमन जो है, स्मॉलेस्ट पावर ऑफ ईच कॉमन, जो हमारे पास कॉमन है उसका स्मॉलेस्ट पावर. इफ वी राइट दिस इन द टर्म ऑफ पावर, देन हाउ वी विल राइट? लाइक, अंडरस्टैंड दिस वन, 2 power 1 into 3 power 1 into 5 power 1 into 17 power 1. This can be written as 2 power 2 into 23. Understand? And it is having power 1. ये जो डिफिनेशंस है इसको यहाँ पर इंप्लीमेंट करते हैं. स्मॉलेस्ट पावर ऑफ ईच कॉमन प्राइम फैक्टर, स्मॉलेस्ट पावर ऑफ ईच कॉमन. हमारे पास दो नंबर्स है, वी आर हैविंग 2 numbers and smallest power of each common now in which only 2 is common. Remaining other prime factors 3, 5, 17 and 23, they are not a common prime factors, they are not common, ये common नहीं है. We are having only 2 prime number is a common, it is coming in the both the numbers. इन दोनों का जो factors आए उनमें सिर्फ 2 common है. अब यहाँ पर 2 की पावर 1 आ रहा है, there is a 2 power 2. So we will use smallest power of each common prime. Now there is a clear है, यहाँ पे बिल्कुल क्लियर हो गया कि जो कॉमन नंबर है, कॉमन फैक्टर है, उसकी स्मॉलेस्ट पावर. Now it is having 2 power, it is having only 1 power. So we will consider what? Smallest one. So we will consider 2 power 1. So 2 power 1 will be what? 2. So this is the answer. So from the definition I explained this one how it is coming. Now next one is what? LCM. And LCM निकालने के लिए जो भी प्राइम नंबर्स इन्वॉल्व हुए हैं, इन नंबर्स के जो प्राइम नंबर्स हमने निकाले, प्राइम फैक्टर्स निकाले, उनमें जो जो भी प्राइम नंबर्स है उनको 1 टाइम लिखेगा. राइट द 1 टाइम ऑफ प्राइम नंबर्स इन्वॉल्व इन द नंबर्स. इन नंबर्स के अंदर जो भी इन्वॉल्व हुआ है, 2 हुआ, 3 हुआ, 5 हुआ, 17 हुआ एंड 23, 1 टाइम. 2 into 3 into 5 into 17 into 23. Observe, 2, 3, 5, 17 and 23. These prime numbers are involved in these 2 numbers. Only 1 time we are writing. Then greatest power of each prime factors involved. Greatest power, take greatest power. What power? Greatest. Now 2 की greatest power कितनी है? 2 यहाँ भी आया, यहाँ भी आया, लेकिन we will use greatest power. So greatest power is 2, so we will consider 2. And remaining all are having 1, so we will consider 1. Like this. सबसे पहले first for the LCM we will write whatever prime numbers involved in the numbers. इन नंबर्स के जो प्राइम नंबर्स बने हैं उनको 1 टाइम्स लिखो और उनकी ग्रेटेस्ट पावर लिखेगा. इसमें 1 टाइम आ रहा है, इसमें 2 टाइम्स आ रहा है. वी विल कंसीडर मैक्सिमम पावर, ग्रेटेस्ट पावर. सो वी आर राइटिंग दिस वन. नाउ मल्टीप्लाई. दिस इज द 4, दिस इज द 5 3 जा 5 3 जा 5. दिस इज 1 is what? 1 time I am writing like this. 3, 5, 17 and 23. Now I am multiplying. 4 3 ja 12, 4 3 ja 12 and 12 5 ja 60. 12 5 ja is 60. Yes or no? 5 3 ja 15, 15 4 ja 60. Clear? Into 17 into 23. Now multiply. Table till 20 tables. If we know well, these tables are useful for calculation in this chapter. Now multiply 16 directly to 17. How many times it is going? 0 first. 17 6 ja 17 6 ja is 100. 17 5 ja is 85. What is 17 5 ja is 85 and 17 6 ja is what? 102. 102 102. And then multiply this to 23. And what result I am writing there? 10220. 102 multiply by 23. So we will multiply 102 by into 23. Directly I am doing. We will use 0 directly. So 0 will be there. Then 3 2 ja 6, 0 3 4 0 2. 6 4 3 2, and already we are having 0, 2 3 4 6. So this will be the product. So what is the LCM? LCM 23460 will be the LCM of 510 and 91. Now one question is there, what is the use of this number? Why we are finding LCM? Why we are finding LCM? हम LCM क्यों निकाल रहे हैं, क्या यूज है? सो LCM इज द लीस्ट नंबर, लीस्ट कॉमन मल्टीपल. ये नंबर ऐसा है जो ये दोनों को, इफ वी डिवाइड 510, it is divisible. This is a common number. But both numbers 510 and 92, both we use and we divide from this one, then we are getting remainder equal to 0. So it is a common number, and it is what we will use as a least common multiple, LCM. So if we are having 510 and 92, then its LCM of these two numbers will be 23,460. Then 510 is going completely and this is also going completely. So we are doing LCM. Clear? Now we want to verify this question also, and what is the verification? LCM into HCF equal to product of both number. Now I am going to verify. For verification, first we know the formula, HCF into LCM should be equal to product of both the numbers. If two numbers A and B, A is 510, B is 92, then product will be the what? HCF is 2, and this is the 23460. Now A is 510, B is 92. Do carefully. If we are getting left hand equal to right hand, then we can say whatever we find HCF and LCM there will be correct. We are multiplying by 2, 0, 6 2 ja 12, 1 is remaining, 4 2 ja 8 or 1, 9, 3 2 ja 6, 2 2 ja 4. In the right hand side, first use 0, then multiply 92 and 51. This is 2 9, 5 2 ja 10, 1 is remaining, 9 5 ja 45, 45 plus 1 46, 2 9 6 4, 4 6 9 2 0. Left hand side is equal to right hand side, so we can say HCF is 2 and LCM is what? 23460 of given two numbers. So this is the process of finding LCM and HCF of two numbers, and we also verified and checked this for these two numbers. Now I am going to solve question number third one of question second. I am giving solution of NCERT, new NCERT, and because that solution will be useful for new NCERT, I am not using old one, so please follow new one, then you can getting something. Now third one, question number 2, third one. What is the question? 336 and 54. Same process we will be follow there. Do the prime factorization. 3 3 6 and 5 4. First I am doing this one. Even place having 6, so it is divisible by 2. 1 6 8. Clear? Again unit place is 8, so it is divisible by 2. 8 times 4 times. And unit place is 4, so it is divisible by 2. How many times? 4 times, 2 times. Again unit place is 2, so it is divisible by 2. 2 and 1. Now it cannot be divided by 2, so we will use next prime number 3, and for divisibility of 3, Sum of the digits must be the multiple of the 3. Now 2 plus 1 3 and 3 is the multiple of 3. So how many times? 7. 7 3 are 21. Now 7 is a prime number, so it is going itself one time. Take this one. Take this one. 2. How many times? 2 times 1 7 27. We cannot divide by 2. Next prime number we will use what is the next prime number? 3. So sum of digits, and it is in the table of 3, so we can directly divide. It is a multiple of 3. How many times? 9 times. It is a multiple of 3. How many times? 3 times and 1. This one. Now write the factors. 3 3 6 equal to 2 into 2 into 2 into 2 into 3 into 7, and this one can also be written as in the form of power. 2 power 4 into 3 power 1 into 7 power 1. Clear? Now next one, 54. Write factors 2 into 3 into 3 into 3, and it is written in the form of power. 2 power 1 into 3 power 3. Clear? Now write HCF and LCM. First HCF, and what will be the HCF? HCF is what? Smallest power of common prime factor. Smallest power. We written in the form of power. Smallest power. First check what prime number is common. 2 is common, 3 is common, 7 is there but 7 is not there. यहाँ पर 2 और 3 ही common है, बाकी नहीं है. So in the common prime, each common prime numbers prime factors we will use smallest. तो यहाँ पर ये जो common है, common की smallest power. common क्या क्या है यहाँ पे? यहाँ पे common है 2 और 3, इसके अलावा नहीं है. 7 is there but 7 is not there, so we cannot use 7. So common one is what? 2 and 3. 2 and 3 are the common one. So smallest power of 2, it is having 4 power but it is having only 1 power. So smallest one, सबसे छोटी जो पावर, यहाँ पे 4 है, यहाँ पे 1 है, हम छोटी पावर लेंगे. So 1. यहाँ पर 1 है, यहाँ पर 3, we will not use 3, we will use 1, like this. So this can be written as 2 into 3, and this will be 6, and 6 is the what? HCF. Directly if you want to do, you can find HCF. 2 is there, 2 is there, 2 is there but is not there, 2 is there, not there, 2 is there, not there, 3 is there, we can use only 1 3 there, 3 is there but not in which, 3 is there not in which, 7 is there but 7 is not. Take 2 into 3, 2 into 3, same. So both way is correct, we can do. Now we want LCM. How we will find LCM? LCM निकालने के लिए जो भी प्राइम नंबर्स फैक्टर्स के अंदर आए हैं उनको वन टाइम लिख दीजिएगा. 2 आया है, 3 आया है और 7 आया है. क्या एनी अदर प्राइम नंबर इन्वॉल्विंग इन दिस 2? नो वन. We are having 2 3 7, 2 3 2 3. Now put power. How we will put the power? Maximum, greatest power of each prime factor involved in the numbers, greatest one. So 2 की greatest power, there is a 1, there is a 4, so we will use 4. 3 की greatest power 1 3, so we will use 3. 7 की greatest power only 1. So how we will solve? 2 4 ja. What is the 2 4 ja? If you don't know, you can write like this: 2 into 2 into 2 into 2. What will be the result? 2 2 ja 4, 4 2 ja 8, 8 2 ja 16. So this is the 16 into 3 power 3. If you don't know, you can write like this: 3 into 3 into 3. 3 3 ja 9, 9 3 ja 27. 9 3 ja 3 3 ja 9, 9 3 ja 9 into 3, 9 3 ja 27. 27, and 7 power 1 is 7. Now do the multiplication. What? We want multiplication. First 16 7 ja. 16 7 ja it what? 16 7 ja. If you don't know, you can multiply. If you are having some problem, then you can do the multiplication. 16 will be multiplied by this one. 27 multiply by 16. What we are getting? 7 6 42, 4 is remaining, 6 2 12, 12 plus 4 16. Again I am checking, 7 6 42, 2 will be there, 4 is remaining, 6 2 12, 12 plus 4 16. Now leave this one, 7 times it is going and 2 times. What will be the product? 2, 7 plus 6 13, 6 2 12, 12 plus 1 13, 1 is remaining, 4, 4 3 2. So what we are getting, once we multiply 27 into 16, 27 into 16, we are getting 432, 432, and this will be multiplied by 7. Again I am checking this one because calculation is very important. Once calculation done, then no use of this solution. 7 6 42, 2 will be there, 4 is remaining, 6 2 12, 12 plus 4 16, 7 2 2 13, 1 3 plus 1 4. Clear? Now 432 will be multiplied by 7, and how we will be multiply? Observe this one. How we will do? 7 2 14, 1 is remaining, 7 3 21, 21 over 1 22, 2 is remaining, so 7 4 28, 28 plus 2 30, and this is what? 3024 will be LCM of both number. If two numbers are 336 and 54, then LCM will be this one. Now we want to check our result, and how we will check our result? Product of HCF into LCM will be what? A cross B. We will check. Then what is HCF is 6, LCM is 3024, and product of both number 336 into 54. Do calculation well, then we are getting. Now 6 4 24, 2 is remaining, 6 2 12, 12 plus 2 14, 1 is remaining, we can put directly 1, and 6 3 18, again I am checking, 6 4 24, 2 is remaining, 6 2 12, 12 plus 2 14, 1 is remaining, 1 we will putting there, 6 3 18. Now right hand side should be equal, then only we can say HCF and LCM whatever we find will be correct. Now how we will do? I am just doing multiplication there, 33654, 6 4 24, 6 4 24, 2 is remaining, 4 3 12, 12 plus 2 12 plus 2 12 plus 2 14, 1 is remaining, 4 3 12, 12 plus 1 13. Now do by 5, 6 5 30, 3 is remaining, 5 3 15, 15 plus 3 18, 1 is remaining, 5 3 15 plus 1 16. What we are getting? 4 4 8 11 1 and 6 7 8 1. It means we are getting left hand side equal to right hand side. So what we can say, our result is correct. Our HCF and LCM whatever we find there will be correct. Now what we studied in this question, observe. I am again reading this question number 2, exercise 1.1. Find the LCM and HCF of the following pairs of the integers. Two numbers are given, we want HCF and LCM, and verify this one. For verifying we use this formula, HCF of two numbers into HCF LCM of two number product will be product of given two number. Clear? So first question, second question, third question we completed there, and in these questions first we use by long division method to find prime factors, then whatever number is common involved in the numbers will be considered as प्रोडक्ट विल बी कंसिडर्ड एज HCF। जो भी इनमें कॉमन नंबर्स होगा उनका प्रोडक्ट जो आएगा वो HCF होगा। बट फॉर द LCM मैक्सिमम पावर वॉट एवर प्राइम नंबर्स हैविंग इन दीज फैक्टर्स, in these two numbers whatever factors we are having, whatever prime numbers used will be write one time and we will consider maximum power। जो भी प्राइम नंबर इसमें आया है उसको वन टाइम लिखेगा, उसकी मैक्सिमम पावर हमें कंसीडर करनी है, लाइक दिस। नाउ आई एम गोइंग टू डिस्कस नेक्स्ट क्वेश्चन एंड नेक्स्ट वन इज व्हाट, क्वेश्चन नंबर 3, फाइंड द LCM and HCF of the following integers by applying the prime factorization method। but what is the difference between both question? In both we have want to the HCF and LCM, but in this question two numbers are given, one pair is given, pair of integers are given, but in these questions three numbers are given। if 3 numbers, 4 numbers, 5 numbers are given, we can find the HCF and LCM, no doubt at all we can find। process will be the same, first we do the prime factorization, then we will use this definition, and if both two numbers are there, common will be, common prime factors product will be what, HCF, and greatest power of each prime number involved in the number will be what, LCM। clear? I am trying to solve question number 3rd first one, question number 3rd first one। question number 3rd first one, I am taking there question number 3rd first one। what is the question? 12, 15 and 21। now in this question 3 questions are given, so we will do each number's prime factors। so how we will do? by using long division। I am using 12, then 15 and then 21। so 12 it is divisible by 2, no doubt, unit place is having 12, 6 times 2, 3 times again, now used 3 one time, now it is not divisible by 2, use 3 how many times, 5 times, 5 one time, now this one we cannot use 2, we will use 3 how many times, 7 times, 7 is prime, we will use like this, then write like this, 12 can be written as 2 into 2 into 3, and in the power form 2 power 2 into 3 power 1, and 15 can be written as 3 into 5 in the power form 3 power 1 into 5 power 1, and next one 21 can be written as 3 into 7 and in the power form 3 power 1 into 7 power 1। now HCF and LCM, HCF will be what, HCF is what, smallest power of each common prime factor, smallest power of each common prime factor। now in this we are having 2, but 2 is not there, 2 is not there, so we cannot use 2। now 3 is there, 3 is there, 3 is there, and in which only one number is common, remaining are not common, and common numbers smallest power 3 one time, 3 one time, 3 one time, so we will use 3 power 1। what will be the HCF? 3 power 1, and answer is 3। गेटिंग और नॉट? इसमें 2 है, यहाँ नहीं, यहाँ नहीं है, इसमें 2 यहाँ नहीं, नहीं है, 3 है, 3 है और 3 है, 5 यहाँ नहीं, इसमें नहीं है, 7 नहीं है। सो जो कॉमन है उसकी स्मॉलेस्ट पावर वी विल यूज इन द HCF। नाउ हाउ वी विल फाइंड LCM? इजी, LCM। नाउ व्हाट इज LCM definition? Greatest power of each prime factor, greatest power of each prime factors involved in the numbers। जो इन नंबर्स में ग्रेटेस्ट पावर ऑफ ईच प्राइम फैक्टर्स हमें इन्वॉल्व हुई है उसको कंसीडर करेंगे। सो बेटा इसके लिए सबसे पहले हमें देखना होगा एलसीएम के अंदर कौन कौन से प्राइम नंबर्स इन्वॉल्व हुए। तो इन फैक्टर से हमें पता चला है 2 हुआ, 3 हुआ, 5 हुआ और 7 हुआ। सो राइट वन टाइम 2 इंटू 3 इंटू 5 इंटू 7, 2 इंटू 3 इंटू 5 इंटू 7, 2 3 5 7 जो इन्वॉल्व हुए हैं उनको वन टाइम लिखो। देन यूज ग्रेटेस्ट पावर। नाउ 2 की ग्रेटेस्ट पावर 2 है और है ही नहीं, तो 2 की ग्रेटेस्ट पावर 2 आएगी। 3 की ग्रेटेस्ट पावर क्या है 1, 5 की ग्रेटेस्ट पावर 1, 7 की ग्रेटेस्ट पावर 1, 2 2 जा 4, This is 3, this is 5, this is 7. 4 3 ja 12. 12 into 5 into 7. 12 5 ja 60 into 7. And 7 6 ja 42. And this is the answer. So in this way we calculated what? HCF and LCM of given 3 number. Clear? I hope you are getting these sort of the questions. Now I am going to take next one, question number second one. In this question we want only HCF and LCM, not what? We want only HCF and LCM, not verifications. Clear? Now third one, second one. And what is the second one? Third second one is 17, 23 and 29. These all are the prime numbers. 17, 23, 29. These all are the prime numbers. Do the prime factors. 17, it is going itself one time. 23, it is going itself one time. 29, it is also a prime number going itself one time. Now write in the factor form. 17 can be written as 17 into 1. 23 can be written as 23 into 1. 29 can be written as 29 into 1. Now we want HCF, and by definition what we can say, HCF is a, what is HCF? By the definition we can say HCF is the smallest power of each common prime factor. Each common prime factor, यहाँ पर जो कॉमन प्राइम फैक्टर है उसकी स्मॉलेस्ट पावर है. नो प्राइम नंबर इज कॉमन देयर इन विच नो प्राइम नंबर इज कॉमन. इफ नो वन इज कॉमन then we will use HCF equal to 1. 1 is not a prime number. 1 is neither prime nor composite. But if no number is common, no one is, no factor, no prime number is common, then what will be the HCF? HCF equal to 1. Clear? So in this question HCF value will be 1. Now LCM. Now what will be the value of LCM? Whatever prime factors involved in the numbers we will write one time. 17 into 23 into 29, and product of these numbers will be the LCM of given 3 numbers. So you can do this product and you can calculate the value of LCM of these numbers. Clear? So now I'm not doing product there, so you can try, you can do easy product. If you want you can do 17 3 ja directly. If you know the table then we can easily do 17 3 ja 51. 17 3 ja 51. 1 will be there. What is the remaining? 5. 17 2 ja 34. 17 2 ja 34. 34 plus 5. 34 plus 5 9 3. 391 into 29. Now I don't know the table, so multiply this one. 391 multiply by 29. 9 9 ja 81. 1 will be there, and 8 is remaining. 9 3 ja 20. 9 3 ja 27. 27 plus 8. 27 plus 8. 9 9 ja 9 1 ja 9. 9 9 ja 81. 1 8 will be remaining. 9 3 ja 9 3 ja 27. 27 plus 8. 7 7 2 ja 14 plus 5 1. 1 is remaining 3. 35. Yes. Now 2. 2 times 9 2 ja 18. 1 3 2 ja 6 or 1 7. Do the carefully, then only we are getting 9 3 8 5 13. 8 plus 5. 8 plus 5 13. 1 is remaining. 8 8 plus 3 11. Again I am observing 9 9 9 ja 81. 1 8 is remaining. 9 3 ja 27 plus 8. 27 plus 8. 5 plus 3 35. No doubt. Clear? 2 9 2 ja 18. 1 3 2 ja 6 or 1 6 or 1 7. 9 3 8 plus 5 13. 8 plus 5 13. And 1 is remaining. 7 plus 3 10. 10 plus 1 this one. So product will be 11 3 3 9. Do the carefully, then only you will get. So this is the solution of question number 3, second one. Now I am taking question number third one of this question. And what is the question? What is the question? Question number 3, third one. Question is 8, 9, 25. 8, 9, 25. 3 numbers are there. We want HCF and LCM. Do the prime factors. Easy question. Small numbers are there. So no more time will be required. We can easily to do because so many questions we completed there. Dividing by 2, 4 times 2, 2 times 2, 1 times. Clear? 3 times directly we are doing because it is divisible by, not divisible by 2. We can use 3. 5 cannot divide this one by 2 and 3. We will use 5 times and 1. Write in the factor form. 8 can be written as 2 into 2 into 2. And 9 can be written as 3 into 3. And 25 can be written as 5 into 5. So this is what? 2 power 3. This is 3 power 2 and this is 5 power 2. So we want HCF. So what will be the HCF? HCF is what? Smallest power of each common. Which one is common? No one is common. There is a 2, there is a 3, there is a 5. No one is common. If no one is common, then HCF is what? 1. LCM. What prime numbers we used there? Having in these numbers 2 into 3 into 5 and put the maximum power. It is 3 times. No other number is there. It is 2 times and it is 2 times. Solve this one. This is the 8, this is the 9, this is the 25. Product. 9 8 ja 72. 9 8 ja 72 into 25. Do the product. 25 2 ja 50. 5 is remaining. 5 is remaining. 25 7 ja 25 6 ja 150. 25 6 ja 150. 25 7 ja 175. 175. 8 5. What we are getting? 180. This is the LCM of these numbers. So easy question. If no number is common, then HCF will be what? 1. And we will do like this. This is the question number third one. I completed there. Now next question I am taking. And what about the next question? Next question I am taking there. Next one is question number 4. And what about the question number 4? Given that HCF of 2 numbers equal to 9. Given that HCF equal to 2 numbers equal to 9, find the LCM. 2 numbers. In the bracket we are having 2 numbers. And HCF of these 2 numbers given. We want LCM of these 2 numbers. 2 numbers. So we know from this question we know this formula. HCF of 2 number into LCM of 2 number will be product of both number. Now AB is what? 2 numbers. 2 numbers given in the bracket. A cross B. So in the bracket whatever numbers are given, they are the 2 numbers. So what is the LCE? What is the HCF of 2 number? HCF of the 2 number is 9. LCM of the 2 number we want. So put as it is. Equal to 2 numbers. 2 numbers are 306 into 657. 657. So what will be the LCM? LCM will be, this is the multiplication, so this will be went to where? Denominator part. 306 into 657 divided of 9. Now solve this one. This is in the multiplication form, so we can simplify. If there is a plus or minus, first we solve plus minus, then we will simplify. So this is the multiplication, so we directly simplify. How many times? 3 times. How many times? 1 time, 0 and 2 times. It is going 3 3 ja 9. 1 time 0, 3 2 ja 6. Now again sum of these numbers, sum of the digit of this number, 1 plus 0 plus 2, 3, and it is a multiple of 3. So again we can divide one time. How many times? 3 times. What is the remaining? 1. 3 4 ja 12. So what is the remaining? 34 into 657. Product this one will be the result. 6 5 7 34. Do multiplication. 7 4 ja 28. 2 is remaining. 2 is remaining. Clear? 5 4 ja 20. 20 plus 2 22. 2 is remaining. 6 4 ja 24. 24 plus 2 26. Check carefully, otherwise you will get wrong answer. Now next one. 7 3 ja 21. 7 3 ja 21. 2 is remaining. 5 3 ja 15. 15 plus 2 17. 7 will be there, 1 is remaining. 6 3 ja 18. 18 plus 1 19. 8 3 6 6 12 plus 1 13 1 9 plus 1 10 12 1 2. Again I am checking. 7 4 ja 28. 7 4 ja 28. 8 will be there, 2 is remaining. 5 4 ja 20. 20 plus 2 22. 2 is remaining. 6 4 ja 24. 24 plus 2 26. 7 3 ja 21. 2 is remaining. 5 3 ja 15. 15 plus 2 17. 7 will be there, 1 is remaining. 6 3 ja 18. 18 plus 1 19. 8 3 13 1 12 and 1 2. So result will be what? 2 2 3 3 8 will be the LCM of this one. So what we want in this question? In this question, given that HCF equal to 306,657 equal to 9. HCF of two number is given. We want LCM of these two numbers. So we are having one formula. And what is the formula? Formula is that, what is the formula? HCF of two numbers into LCM of two numbers will be what? Product of both numbers. So we can say 9 is the LCM. So not LCM, HCF, we want LCM and product of both number. LCM will be this one. We simplify, then we are product this one, we are getting this is the solution of LCM. In this exercise we are having 7 questions. In the chapter 1 exercise 1.1 we are having 7 questions. Out of these questions 1 to 6 we completed there. Now one question is remaining. Now I am going to discuss that one. And what is this one? I am reading. There is a circular path. What? There is a circular path around a sports field. We are having one circular path around a what? Around a sports field. Sonia takes 18 minutes. Sonia takes 18 minutes to drive one round. We are discussing about the circular path. We are having one circular path and Sonia takes 18 minutes to drive one round. एक राउंड करने के लिए सोनिया को 18 मिनट्स टेकिंग ले रही है. While Ravi takes what? While Ravi takes, Sonia takes 18 minutes to drive one round. While Ravi takes 12 minutes. Ravi takes 12 minutes to 12 minutes for the same. जो सर्कुलर पाथ है सोनिया ने 18 मिनट्स लिए, रवि ने उस सर्कुलर पाथ को राउंड करने का 12 मिनट्स लिए. सपोज दे बोथ स्टार्ट्स एट द सेम. वी आर एज्यूमिंग देयर both starts at the same points. Ravi and Sonia starting at the same point. Both starts at the same point and at the same time. Time is also same and go in the same direction. Ravi and Sonia both are taking a round around a circular path They are starting this round at the same time, same place and same direction, same point, same time, at the same point, same time and go in the same direction. So after how many minutes will they meet again at the starting point? जहां से उन्होंने अपना राउंड स्टार्ट किया था वहां पर वो कब मिलेंगे? Where they will be meet at the starting point. So starting point we want there, and for finding of the starting points, this is linked to LCM and HCF topic. Yes or no? Ravi takes 12 minutes and Sonia takes 18 minutes. We are having two numbers and two numbers. Another numbers we are not having. Only 18 and 12 two numbers are there. They are starting at the same point, same place and same direction. We want where they will be meet again at the starting point. जहाँ से उन्होंने start किया वहाँ पे कब मिलेंगे? इसके लिए what we will be do for finding, or we can say they will meet again at the starting point at least common multiple of 18 and 12. LCM of the 18 and 12. Once we find LCM of, why we are finding LCM? Because in the LCM least common multiple, and it is the what? Greatest power. All points we are including, all factors, greatest power of each power factors. So for finding, and they will be meet at the starting point when LCM of 12 and 18. So how we can write this one? Question number 7th one and last of this exercise 1.1 I am taking there. And what is this question? Solution of this one I am writing there. So they will meet again at the starting point, LCM of least common multiple of 18 and 12. When जब इन दोनों नंबर्स का हमें लीस्ट कॉमन मल्टीपल मिल जाएगा, देन वी कैन से और वी कैन नो total time required to meet again. So how we will do this one? For finding of LCM we will take prime factors. 18 prime factorization method, how many times it is going? 9 times, 3 times, again 1 times, 12, 2, 6, 2, 3 and 1. So factors of 18 is what? 2 into 3 into 3, and 12 equal to 2 into 2 into 3. This can be written as 2 into 3 square, and this can be written as 2 square into 3. Now we want power of 2 is 1, power of 3 is 1. So LCM of 18 and 12 will be what? For finding LCM we will use whatever prime numbers having in the numbers. So 18 and 12 having 2, 3, only 2 and 3, 2 into 3, right? जो भी हमने प्राइम नंबर यूज आया इनमें उनको लिखेंगे. Then maximum power, greatest power of each prime factors. So 2 is using 1 time, there 2 is using 2 times, so power will be 2. 1 time, and there 3 is using 1 time and there is 2 times, so we will use 2. So do this one. 2 power 2 4 and 3 power 2 is 9, and 9 4 ja 36 minutes. After 36 minutes they will, after 36 minutes they will meet again at the starting point. And finding this starting point we will do what? LCM of given numbers 18 and 12. So I hope you are getting solution of this question. This is the easy question. Two persons, Sonia and Ravi. Sonia is taking 18 minutes and Ravi is taking 12 minutes, starting their round at the same time, same place and in the same direction. So When they will meet again at the starting point. For finding these types of the question value, we will do the least common multiple, and least common multiple will be what? 36 minutes. After 36 minutes they will meet again at the starting point. So this is the solution of question number 7. So what we studied, I am just revising what we studied in this class. In this class, I am taking exercise 1.1 real numbers. So, in which this exercise we are having 7 questions. All questions I am completing there, and first question is linked to prime factorization, and this is important for the solving of question number 2, 3, HCF and LCM, and another question number 4. So, and this question is also linked to HCF and LCM. So we can say in this exercise only 2 things we should know. One is the prime factorization, and for prime factorization we will use prime numbers, and we will use what method? Long division method. And in the HCF and LCM, HCF 2 numbers के लिए 3 numbers का हो सकता है. HCF और LCM 2 numbers and 3 numbers we can find. But what about the HCF? दोनों नंबर्स के अंदर जो प्राइम नंबर कॉमन होता है, और वी कैन से व्हाट? स्मॉलेस्ट पावर ऑफ ईच कॉमन प्राइम फैक्टर्स इन द नंबर, स्मॉलेस्ट पावर, लाइक दिस वी कैन से. बट LCM, greatest power of each prime number involved in the numbers, greatest one. So in this, for board point of view, I can say this exercise is having only 2 questions. First we know the prime factorization, then we can find HCF and LCM. So do practice well, revise this class again and again. You will get more and more knowledge, and you will get perfection in your this exercise. Thank you so much.